Hey everyone, welcome to Go to Kamikaze YouTube channel. I hope everybody are doing good. So in the last videos, containing to the machine learning and Mlops, which is the machine learning operations, we had discussed about machine learning basics, and we had discussed about what type of machine learning stages we have and architecture and all. So continuing in this series, so today we are going to discuss about a sample project. So what we will do, we will automate that project by applying DevOps principles for the machine learning, project. Which means we have the entire machine learning code with us. So I have created a project for that, and what we will do, we will deploy that project into the target environment by applying the DevOps principles via CI/CD pipeline. So there's the agenda for that today. And let's not wait. Let's not wasting the time. So let's deep dive into the concept that we are gathered here. So as I mentioned, so today we are going to discuss about a model. It's a model where I have, it has some kind of code that I have written, and it has been using logistic regression, and that is going to predict whether the person will purchase a product or not. So whether he's going to purchase or not. So I have two features. One is age and salary. So for that, I have taken some sample data, hard coded into my local itself, not make complexity. So I'll show you what all hard coding I have done and what all best we can do in terms of productionization. We'll discuss each thing in a line in a series. So yeah, so in this video, like what we are going to discuss about, whatever model that I'm going to show here, what is going to predict, what is output. So my model here, it is going to predict the binary outcomes. So which means like a prediction whether the person is going to purchase or not based on the age and based on the salary. So my output will become like 1 or 0. So if the 1 comes, the person will purchase the product, and if the 0 will come, so the person will not purchase the product. So this logistic regression is going to predict those, and it will give output. I'll show you output in a postman, and how does it look like by based on the data and based on inputs that we are going to give it. So how it works? So the model that I have written here in this project, this model is trained on kind of data set that I have hardcore in my file itself, which is data collection.py, which is looking appearing here. Um, like where each like in the data set, we have a separate different entries. So each entry has a person age and person salary, and this model has trained whether the person purchased the product based on the column value that I mentioned, 0 and 1. So once it's trained, and the model can take new persons, I have some data set which is old, I have trained that. So once it is trained and once it is up and running, the model can take a new uh, new person age or person salary as input, and it will predict whether they are like to purchase the product or not. So thus the model is going to be trained. I will show you how it is going to train, and I'll walk through each file that have added here in this presentation. So if I give example, if the age, if the input of the age that, like example, 30, and the salary is 40,000. So the prediction, the model might predict one, because the person is like to purchase the product based on the data that we are given. So to make just simplification, I brought these features, age and salary, and we have a number of issues that are currently going on real world. So you can create your own machine learning model. You can train the data, so you can simplify the different problems. So just to make you understand easily how you can create a machine learning project, and how we can perform all the operations. So I thought not to make more complexity. So I just have taken a data set where it has the age and the salary, and I'm going to train that agent salary to the my machine learning model, which is logistic regression, and that model will give whether this person is going to purchase the product or not. So sweet and simple, not complexity. So make you understandable more easily. And if you see here, like here we are going to take the a Flask. So Flask is a web framework that we can use to build web applications in Python. So here I have integrated the web application with the machine learning model. And if you see here, we have been importing few libraries such as pandas and numpys. Both have used to used for data manipulation and numerical operations. And we have the Skytlearn, sorry, my bad. So usually this library, it's give a various kind of machine learning tools, including like logistic regression and utilities for data pre-processing, such as we have the standard scalars and model evaluation, which is accuracy score, and we have the confusion matrix qualification reports, which comes under the model evaluation, and the data splitting, which is training the test splits, so it will give it. And we have the different, like all the imports that I have imported here, model evaluation, visualization. So it's more into like it's more into the importing the files into the app.py. Other than this, nothing much. But yeah, so the mostly we are going to use in this session pandas and numpys and skytler. So these are all things that we are going to use, and this line app Flask name, which is initializing the Flask application. The Nothing much complicated, and these all things that I have registered here as a blueprint with a Flask, which I have been calling from the as a route from the files that I have split as per each your machine learning stage. We have the data collection, data pre-processing, and EDA. Lay over the Docker file. We'll discuss about Docker file, and we have the EDA, feature engineering, and model training and model evaluation and predict, and we have the visualization.py. So we'll discuss about each of them. But yeah, so if you want to render these all those things, so that's why I have injected as a blueprint with my app.py. So if you see here on the downside, so if my application is running as a home page, it will say that, hey, welcome to the sales production homepage. So this is the homepage that we are going to get. So this text will get once we run this application in our browser. So if you hit uh, IP address with the port number, so usually the Flask runs on 5000 with your local address. So when you hit on that, so the home page, it will be reflect over there. So that's the return message that have added over here as a route, which is a home. So yeah, so this is just basic about app.py. So if you're not familiar with the Flask, I'll add the Flask documentation. Very simple, very sweet. You can easily understand to create the Flask application, not complexity like another framework such as Django. So which is Flask is very micro framework. So within fraction of minutes or hour, based on your interest, you can easily learn and adopt this framework, the Python. Fine. So let's discuss about the first stage in the machine learning here. First one is the data collection. So if I'm going this file, which is data collection.py. So I'm just importing the blueprints. So here, Justinify and Pandas as a PT. So in this, what is happening? Like this data collection. So this endpoint. So this endpoint. This endpoint is create the hard coded data sets, which is representing the age, salary, and purchase behavior of individual. So if you see here, I have a hard coded data set. So like age and salary and purchase 0, 1, 1 not. So which is hard coded, but yeah, usually in a real time. So it can be pulled it from any data sources such as databases or big data or Flask or data lake. So wherever you have the data, so you can use a ETL, extract, transform, load. So you can utilize those features. So let's not make complexity. That's why I've hard coded the data. which is I have age of 22, 25, 47, and so on, and the based on the salary, and whether I, if it is a zero, which is saying that not purchased, it is not going to purchase. So one is a purchase. So I have given three um, hard coded data sets here, and I'm going to create a data frame over here, which is a df panda pd dot data frame. So, and hard coded data, and later I'm going to save the data, which is a df to dot to save, so which is data dot csv. If you see here, it has saved already because I already ran this project, so that's why it is appearing here. So in your case, like, I'm going to add the source code into one of the GitLab repository, so you can download it, so you can run it in local, and you can delete this data csv dot and feature, and these all the csv files, and when you run this endpoint, it will automatically create. I'll show you how it will be look like. And so I have the return statement as a response. So then I have a written the JSON response which confirm the data has been collected, include the data itself. So that's what I have been rendering here. So the data collection, usually, like, you collect the data from different resources, such as I mentioned, any databases or data resources or data lakes, some um, different sources, and you can use the airflows. Different tools are there. You can use those all tools to collect the data. So in our case, we just made a simplification. But yeah, so the first thing, so we are going to call the data collection as a route. So once I run it, so it will create one data.csv. It will create a data frame, and it will save all the data over into the csv file. That's the first thing about the data collection. And the second stage, we have the data pre-processing. So in this data pre-processing cycle, first thing, it's going to read the data. So which means, like, data.csv, whatever we have saved here, it is going to read the data and using the pd.read.csv. And next one is going to handling the missing values, such as df dot drop na, and we have mentioned in place is equal to true, which means, like, drop any row with the missing values. These steps, like, usually because the data is hard coded without missing value, so it is minimal. I can say that this step can be very minimal because we don't have bulk data. We have already hard coded data. We do not have any kind of missing values. But yeah, so as a part of data pre-processing, we just have done that, and whatever clean data we have, we are going to store into the pre-processed underscore, if you see here, pre-processed underscore data.csv, and we are going to save over here. And we have the response, such as a JSON response, which saying that, hey, data pre-processing successfully completed. This is the second step. So not more complexity. Even we don't have a bulk data to look into. Hey, what all missing values did I drop, and did I make it as a more useful in terms of dropping the values, or which are the missing values. There is no much complexity. We just have hard coded very minimal data, so it is very easier to understand. Fine. So this is about data pre-processing, and the next is exploratory data analysis. So in this, where, like, we are going to reading pre-processing data, like, whatever data has been pre-processed. So first we are going to read it, like pd.read.csv, and here, like, in this uh, in this df dot describe. So what we are going to do, we are going to calculate the descriptive statistic, which is a mean, standard deviation, and minimum and maximum, etc., for each column that we have into the CSV file. And next we have the correlation matrix, which is a df dot core. So what is it usually do? Like, it's compute the correlation between the features, such as we have the features such as age and salary and purchase. The last one, it will return the response, which saying that, hey, the endpoint returns, like, usually statistic correlations of JSON format. It will show all the JSON format. I'll show you how does it look like in terms of EDA. The next one is a feature engineering. So in the feature engineering, like, first it is going to read the pre-processed data, which has been getting lowered, which is same for here, like a EDA. And now the first one is, like, it's going to scaling the feature, which is a standard scalar I have used here. So this standard scalar is used to standardize the age and the salary feature, where you can use this as scalar. And now I have used a fit transformation, like what it exactly do. It's going to scale the data that it has the mean, which of 0, and the standard deviation of 1, which can improve the performance, like of many machine learning models that we can use this fit transform. And the next, now I'm going to save the model, like here, which is a features underscore dev.csv, whatever I have used, taken as the data frame, which is age and salary. Now I'm going to return the JSON response saying that, hey, my feature engineering completed, this is the data frame. Fine. Now it's going to be model training and model selection, we called regularly. So in this, what is happening, first I'm going to train the data. I'm going to uh, train the first we are going to splitting the data first, which is train underscore test underscore split. I'm going to utilize that. So here what I'm going to do, I'm going to split the data into training, which is testing of 80%, and training of 20% for the data. So if you see here, here we're having extra and x text and white, right? So here x contain the features such as age and the salary, and y contain the targets value such as purchased or not. So this is all the features that have been going to splitting the data. And the next, I'm going to train the model. So I'm going to use a logistic regression over here. I'm going to initialize the logistic regression after that, and I'm going to fit x underscore train, y underscore train, which is the train the model, which using the training data set that we have. And then now I'm going to save the model parameters such as np.save. I'm going to save over here, and I'm going to save this as the like a learning coefficient of model. So I'm going to use model npy and intercept.npy and model underscore intercept, which is going to save the intercept terms. So after saving that, I'm going to write the response saying that, hey, model training is successful, and this is the coefficient, and is going to give the coefficient values. And the next one is model evaluation. So in this model evaluation, now we are going to see, first we are going to loading the data and model, and in that, we are going to the data which is read again, we are going to read again. And the next one is model, that is going to coefficient and which is and intercept are loaded from the save file, whatever save file that we have. And now a new logistic regression model is initialized in this. And if you see here, now new logistic regression model is initialized, and it's going to load the coefficients and the intercepts or assigns, which I mean to say that, it is going to call the model dot classes and np dot array 0 and 1, which is manually set the classes of zeros for no purchase and 1 for purchase. So it's going to map those values, and it is going to predict y underscore pred, and it's going to say that, hey, y underscore product and model prediction extend makes the prediction of the test data that we have here. In terms of evaluation, we have the accuracy, which is going to compute the accuracy of the model, and confusion matrix, which is generate the confusion matrix, and classification reports, it will provide the precision and F1 scores of each class. And the last, it is going to give the endpoint, which is accuracy, confusion matrix, and the classification report. So this is about the model evaluation, so that we have discussed. So first, it is going to the data is read again, and the model coefficient and intercepts are load from the saved file that we have already have, and the new logistic regression model will be initiated, and it will be load coefficients and intercepts or will be assigned, and later we will set the manual classes, and it will do the prediction to the test data. So these are all about evaluations, the model evaluation that we're going to use it. We'll see how it will look like while running the application. And the last one, we have the prediction. So in this, in this stage, we are going to predict it the entire um, you know both, like, we're going to provide the both age and salary as input, and now we are going to load all the logistic regression models or whatever we have taken, and we are going to mention the scale fit over here into our source code, and whether age and salary is getting matched or not. So then at the end, like, if the prediction is 0, and we are going to say that, hey, it is going to can purchase, and if it is not, it is not going to purchase. So that's what we are going to do as an input, and the output will be can purchase, cannot purchase. So here we are going to pass all the age and salaries and all. So these all things that we are going to see here. And the next we have the requirement.txt. So these all the things which are required to run this application. Yeah, so fine, like, these all the endpoints, we can say, that our data machine learning stages that we have regularly, we see in daily life, so that we use to predict any machine learning model. So if you want to see the how does it look like, so first we need to go to app.py, and now from here we need to run this app.py, and it can be look different than that you see in your daily life, because to make you more understandable, and I would like to show you on the browser. That's why what I have done, I have created each machine learning method as a route. So whenever I call the route, it will give an output on my browser. So in your case, you can use, or you can go with the different approaches that which may not look similar, that I have brought this project. just I just want to make you more understandable. That's why I brought the new kind of approach to make you understand. But yeah, in a real time, you can use a number of ways to create a machine learning model. You can write the in a single file itself. You can write all these stages. You don't need to create separate files for it. But in a single file, you can write it on all those things. You can call it as directly. So up to you how you would like to create the machine learning project. So that's a quick heads up. So other than that, there's nothing too much added. So now let's go and run this flash.api, app.py. Now let's see how each route can be act, and each route can be you called. Sorry. Oh, it seems to be up and running since my last session has not been terminated. Wait a second, guys. Let me terminate this. Or let me delete this session. I think I can create it from the now here. Okay, so I'm running this app.py. Just you have the play button. Just play it. It will run it. So if you can't find the play button, if you're running in your console, what you can do, you can use the Python or Python 3, and you can call the app.py. So this is the command that you can use to run the Flask application. So these are the basic information. So if you are in production, just now it is debug mode is on, and it gives some inputs, and it is ask you to use website gateway interface. So basic information from Flask, not much complicated. So my application has been running on this IP address with the port number 127.0.0.1:5000, and it has been started. Now debug mode is activated. This is debug pinned if you want to do the debug. So I don't do much complexity. So what I will do, I think I have already copied this. Let me copy again. So I'm going to this browser, any browser. It's up to your wish. So you can just paste over here. So if you press enter, what is going to say that, hey, welcome to the sales prediction homepage. So just because of why it is rendering, because in our logic we have mentioned that, hey, if anybody is coming into my homepage, just hitting this IP address along with the port number, so you have to just give a welcome page saying that, hey, welcome to the sales prediction homepage. That's the thing. And now we are going to see how each route can be acted. So if you see here, each method has own route. So data collection and data pre-processing. So all the routes are present over here, which is in the module register blueprint. So what I will do, I'll copy this one, and I'll see how the data can be collected, and how the collection data can be print into my browser. So I'm going to hit the first stage into the machine learning method. So if I hit enter, if you see this, we have the data, which is age and purchased and salary, and the message saying the data collected successfully. This is what we have seen right here into the data collection. So we have the age, and we have the salary, and we have the purchased or not. So we have denoted zeros and ones. So that's what it is like, nothing much complicated. So we're just printing the data, which means like we're collecting the data. So in our case, we have hard coded here, but in the best practices, you can get it from different databases or data lakes. Fine. So we have seen the data collection. Now let's do the data pre-processing. So here, let's call this data pre-processing one. So what it will do is going to pre-process the data, and if I enter this, one second. So if I do data pre-processing, so if you see here, we have the data pre-processed successfully, and as you know, this endpoint creates the hardcore data sets, which is representing the age, salary, and the behavior of our individual. And it creates the data frame from the hard coded, and it is have saved the data that we have seen, right? So it has saved the data into data.csv. If you see here, we have age, salary, and purchased. So this is age, this is the salary, whether he's going to purchase or not. So this is the thing that we have seen here, which is data collection.py. So data preprocessing.py. So we just have saved all the data, and that's the thing. And the next we have the oh, sorry, my bad. I mentioned data pre-processing. Sorry, it's data collection. My bad. Oh, how can I ever forget that? So the data collection, the endpoint that we have hard coded. My bad, guys. Like I just sidetracked it. I got the one another call, so I was distracted. Sorry for that. So quick correction, guys. In this data collection, so whatever endpoint that we are going to create it as a hard coded asset, agent salary, which is behaving the purchase behavior. So we are going to save the data into the file name called as data.csv. So this is the data collection that we have seen. But yeah, when it comes to data pre-processing, this is the next stage in this data pre-processing. We are going to whatever data that I have saved, we are going to use the data and handling the missing values, which is in data pre-processing, and drop any rows that we have missing the values. So since we don't have much values over here, it's not big deal to do this data pre-processing. But yeah, don't be confused. So let's use this data pre-processing. So in this data pre-processing, we have seen it is going to drop any missing values and rows, and it's just going to clean the data. And if you see here, data pre-processing is successful. So if you see here, we are going to store the pre-processed data, which is clean data, into pre-processed underscore data.csv over here. So this is the same data set, since we don't have machine value, that's why seems to be similar. But yeah, so I've seen it is going to clean all the data sets and all, and it's going to drop any rows and missing values. Yeah, these are all things that we can do in data pre-processing. So the next is EDA, which is exploited data analysis. If you see here, we have the endpoint over here, and if you go and call this EDA, and it will give the correlations, purchase, salaries, and all, guys. So now as we all discussed, here we are going to whatever the process data is there, so it is going to read the data frame, and it is going to calculate the respective statistics, mean, standard deviation, as we discussed, minimum, maximum, so on each column. So we have the correlations, purchase, not, and summary stats, and we have the purchase salaries and all. So in this EDA, we are going to perform this all the activities. And the next we have the feature engineering. So the most important thing here. So in this feature engineering, already discussed, we are going to use a standardized agent salaries as a feature, and we are going to feed the transform, and after that we are going to save the feature underscore dot as a CSV, and now we'll render the response. The response of feature engineering is completed. If I go and hit this endpoint, it will give the feature engineering. So it is going to call the data set and age, but say salary the same way, but here it is going to use the standard scalar, which is standardization for age and the salary. Nothing much, so nothing complicated. If you have a very basic about the machine learning, you can easily on track with my explanation. And the next, we have the model selection and model training. So if I call this this endpoint, so what it is going to do, it is going to train the test fleet, and extend and widen is going to happen. This entire data set will go inject into logistic regression and all. So if I hit enter, So see here, we have the coefficient and the intercept. So, and my model has successfully trained with my data set, which does not have null values with the feature engineering and all. So it has been trained with my logistic regression, and it has been saved model NPY for low. It's kind of coefficients of my model. Like I just have saved the coefficients over here, where it is model at NPY, but it cannot open it, so it requires some kind of different kinds of editor to be looked into since it is saved. And now the next one is model evaluation. Since your model has been trained, now you need to evaluate your model with the 80% to 20% data. So 80% trained data and 20% test data. If I do model evaluation, to say that accuracy, we have very little, like little accuracy. Yeah, we can improve that. um, yeah, so in this model evaluation, so we are going to load the data into model, and we are going to call the new logistic regression, which is initialized, and we are going to look into the coefficients and intercepts which are assigned over here. And finally, we are going to look into the production. How does it look like? And we are going to evaluate the accuracy score, which you can look over here. And we have the confusion matrix and all. So under the down, 1 and 0 and 0, 1 and 0. So these all things can be appear with your data set, which is after train, you're going to evaluate the model. And the next, the final one is a prediction. So since you have your model has been trained, and everything has been now you would like to predict the model. So first you need to give the input values, which is age and the salary for prediction. So you can use browser or you can use any CLI. So my case, like I'm going to use it postman, because I need to send the data. Since these all are the get methods where you are going to get it, but since it is a post methods, because my model has been trained, so now I would like to send some inputs whether it is going to give accuracy values or not. So that's why I'm going to use a postman. So I hope everybody are familiar with the Postman. So if not, so I'll attach the Postman documentation also how we can use it. So since I'm going to use this as a predict, but yeah, as already know that 127.0.0.1 colon 500 5000 is the IP address and port number, and after that you need to select the post as a method and a predict, because now you are going to communicate with your machine learning model which already trained and evaluated. So headers, you need to pass the headers such as context type as a application for authorization, and later you can use a body. In that body, you can base the raw data, which is age and salary. So in my case, age is 18, and oh, I passed. Just testing, guys. Sorry for that. So the person who has age of 18 and the salary of so 17,000, whether he's going to purchase or not. So I'm going to communicate with the machine learning model with this data. So I'm going to give as input. So with this input data, my model has to give a accuracy whether this guy is going to purchase this product or not. So I'm going to send it. So let's see what inputs is going to give. Saying that, hey, this guy cannot purchase because, like, the product value is too high. Let's give a 20,000, which has 18 years of age. Oh, still he cannot purchase. So let's increase the age from 26 and send it. Cannot purchase. Let's give another 0. Oh, this guy can purchase. So with the age of 26 and this amount, what data we have injected, by the way. So data collection. So yeah, 25, 46, 56. Okay, let's see whether this 35 or 40 years age guy can purchase the product or not with this amount. Saying can purchase. So how about 18 years person can purchase this product or not with this age and the salary? Since 18 years person cannot get the salary, but yeah. So let's see whether 48 years of age guy has the salary of 20,000. Let's see whether he's going to purchase or not. He can purchase. And what about 18 years? So there is some less accuracy because, like 18 years is cannot be purchased because that 18 years you may not get the 20,000 salary based on your location where you're getting. So that's why sometimes it can be wrong. So that's why it's saying production cannot be purchased. So if the same age can be increased to 40, so he can purchase, cannot purchase. Oh, and let's increase the salary. 40 years, 40 years guy has been getting more than 18 years, so he can purchase. So this is the input values, guys, like, or you can around with that, like, 35, 40, and increase the salary whether the product can be purchased or not. So you can specify what is the product price, and accordingly you can look into that, like, whether this can be purchased or not. So this is the prediction, guys, like, I am communicating with a machine learning model which was trained with the test data and the train data. So now it is giving the prediction. So let's see, 35 years final one. So 35 years person can purchase or not. So he can purchase it. So this is the response I have been getting, which is prediction under the body. So that's all about. You can see here I have all the predictions over here. I have been doing all the post methods, HTTP, and I have all the success over here. 200 is a success code. So that is all about the prediction, and we have the visualization.py. So if I do this visualize.py, what will happen? Like, it is going to visualize the data that we have the CSV, which is pre-processed data. It is going to visualize it. And if I call it from the browser, I think it is no. Okay, let me call this method into my browser since it is a get method. So if you see here, visualization created successfully, and easy histogram is saved into this path. So you need to create this static directory while you're creating the project, and this all PNGs I have stored into my this location, which is static. So which is a histogram, salary plot, and salary histogram. So let's go to the path. So we have the static here. So if you see here, we have the age histogram PNG. Uh, can I zoom? Yeah. So we have the count and we have the age here, and it is showing this. This is the line over here, and the salary plot.png. So this is the salary and age, and it's going to give the purchase or not with the zeros and ones, and salary histogram. So we have two histograms on the plot, and saying that, like, one is age and the salary, and the other one is age and salary is a combination of combination of curves. So this is a scatter plot where you can play around. We can look into that, all the pre-processed data. How does it look like, and what all chances that have where the person can purchase or not. So you can play around with the data. You can look into that, how beautifully you can visualize with the data that you have pre-processed into your machine learning model. And I think I have covered everything which are required. And Docker file, I'll let you know while we're discussing about CI/CD by deploying this application into the Dockerization and all. So we'll look into that, how we can create the our entire source code as a Docker image, and how we can run the Docker container with the Docker image out of it, and how can access it with the endpoint. So I hope I have covered everything about this project. So we will discuss more into about this project, how we can create the Docker image and how we can containerize it. So we'll discuss how we can create the CI/CD pipeline for this project, and there can be some customization. There can be some changes will be happen. It would not be the same source code will be used for CI/CD. So just to make you understandable easy, so I brought it. So yeah, there can be some little changes going to be happen. But yeah, as I promised, so I have pushed the same source code into my one of the GitLab repository. I'll GitLab and GitHub repository. I'll push for both repositories, and I'll add the URL into the description, and you can go and have access it. And that's all for this lecture. Thank you for watching. And if you have any questions, and if you have not been clarified anything, you can drop your comments into the comment section, and feel free to drop it. Not feel shy. If you understand, drop it. If you haven't understand, drop your concerns and where did you haven't understand. I'll make another video to make you understand well more. And that's all for this video. Thank you for watching. Until then, bye bye.